Hello everyone, today we are going to solve a quiz question. We will be putting the link in the description part. I am Yusuf.
I am Semi.
We may start from the first one. Here we may use a squeeze theorem, I think. So we are going to try for writing an equation. Here we see that we may write as it goes like that. This one also goes like that. And here I see that this part is actually bigger than n, and this part is actually bigger than n over n, since it is like the division of n factorial. So this is the first part of the squeeze theorem, and the second part will be we may use limits, since the question asks for limit. Here is the asked part. And these are all equals. The asked one, and it's sorry for that, and it equals for infinity. So we see that the from the first and second claim, we see that limit n goes to infinity is equals infinity. For the second part, for the second question,
we can also write the by squeeze theorem if we are in quiz, because this always helps.
Yeah, thanks, Semi. This part is the most necessary part, I think. And here, we are going to try for division. We know that this is n over.
I think it is also n plus 1 here.
N plus 1, yeah.
Over n plus 1 to the power, yes.
Thanks, Simi. And here we have, and the question asks for the division and the limit for n goes to infinity. So we are going to try to divide them, but in a different way. This equals this part here. And for that factorial, we are going to write for n plus
n
1
factorial times
n factorial. And since we are going to divide it, we will be writing as like that. Yeah. Here we have, we may delete them, and also we may delete them. Now we have and here, it seems a bit confusing actually, but we have been taught for useful limits in the lessons. So we may see this part as like that. So what the question asks was that limit n goes to infinity as, and we see that it's actually as this form. And from the useful limits to remember, I may write here, maybe, or here. We can say that while n goes to infinity, this equals actually a over x. So here we have a. So we will be having this conclusion, I believe. So now we will be going from the third question. Actually, here we have, you see here, we have been asked the convergence of this series. Here we are also going to use effects from calculus 101. From calculus 101, we know that is actually equals this thing. So we know that to examine it differently, like we will examine it in a separate part. We have this one, so it also actually equals to division of 1 to n minus ln over a. So here, which means we actually have this one. So we also know the p series, which says that if like p is lower than 1, lower and equal than 1, the sequence diverges. If it is more than 1, it converges. So the question asks for a and the convergence. So we are going to go for this equation. So we will be having the equation changes since we product it with -1. So we also have here. So we see that for convergence, a has to be lower than 1 over a. So the solution we have is, that's all for today. Thanks for listening.
Actually, we also need to check the first part. So since it is greater than 0, so we find it for all conditions A, but after we check what is asked in this question, we just change this minus infinity to 0, that's all.
Yeah, thanks. So we have this one. Thanks for listening. Have a nice day.